Hi, welcome everyone. So in the previous session, we have discussed about AI manager skills roadmap, and we identified around 16 set of skills which we have to apply as an as an AI manager while we are working with an organization. So uh, the objective is to apply these skill sets in order to solve our consumers' problem, or in fact, with whichever organization we are working. So we have to apply our skill set to solve their respective customers' issues and problems while we are working as a AI manager. So now we will be applying all of these skill sets across certain use cases and problem statements across different types of industries. So the industries which we are currently targeting is one such industry is Hitachi Digital. Okay. So we are going to discuss today how company context changes the emphasis of an AI manager, uh, the life cycle of these skill sets or the AI manager remains same, but depending on the industry risk and the operating environment change, the depth of each skill would change. Okay, and the order will remain same, but eventually the depth of those skill sets applied according to the use case would change. Now, what are we going to do? We are going to get started with some case studies. Let's say with Hitachi Digital initially. Now here, first we have to cover the following. In this case study, where we will be discussing about enterprise integration, how cloud native AI can be done, how distributed systems can work, how we can ensure global delivery and industrial transformation. So this is what we are going to implement. Okay. Apart from Hitachi Digital, we will be taking care of other use cases also as soon as we progress further. So we'll see some use cases with ENY, Honeywell, Visa, how these skill sets are applied. Okay. Now, for a AI manager, an AI manager needs broad technical fluency. So you need to have an overview of how technology works, but you should have deeper ownership on the strategy side, governance side, and delivery side, delivery of the AI solution. Okay. So these are the areas where we have to focus. So what does an AI manager typically, owns? So an AI manager would own the business outcome. He would own prioritization. He will own stakeholder alignment. Okay. He will have control and ownership over governance gates, delivery decisions, and adoption and scale. Okay. So we are going to see how we are going to perform all of these step by step on a use case, and what we will be owning, and what where we do have to guide and review the results, and what kind of challenges would come which we have to understand and help our team solve those challenges and move ahead and ensure an appropriate strategy governance during the project and delivery. So all of these we are going to implement across the case study. We'll also talk about data architecture. We will talk about RAG and agent design in the upcoming sessions. We'll also talk about cloud platform choices, trade-offs, depending on different cloud, options available while we will be implementing an AI system. Evaluation strategy, ML ops and observability, tracing, all of these would be very, very important for an AI manager to guide and review. Though there would be teams, those who will be implementing, like a forward deployed engineer or a Gen AI engineer. These engineers would be implementing this, second stack. But as a manager, if you have an idea, it would be much better to have to get those strategies implemented accordingly, and to ensure right governance. Similarly, we will also take a quick peek into Python and frameworks. The objective is not to write too much of Python code, but at least have an understanding about how end to end these systems are working. Okay. Followed by model training details, API implementation, understanding of infrastructure tuning, and domain protocols. Okay, these we should be aware of. Now, so the overall implementation which we have to do is initially we have to get started with business problem. What kind of problem a business is facing? Let's say what kind of challenge Hitachi Digital is facing and what are we going to solve? Also, we are going to coin our AI strategy across the problem. Then we are going to ensure governance. We are going to build architecture for the solution. We are going to ensure delivery of the solution, then validation of the responses. Once the validation of the results or outcomes are done, then we ensure enterprise or production grade deployment, ensuring operations, and finally scaling the product as per requirements. So this is what we should have an overall idea of across a business problem. So as an AI manager, our objective is we have to connect business value, we have to govern the AI architecture, we have to ensure cross-functional delivery across cross-functional teams, and we should have measurable production outcomes. Okay. So creating business value, understanding business problems and solving those problems. When we know how we can solve it, governing that AI architecture, which the team is building or deploying in order to solve the problem, ensure cross-functional delivery across teams and businesses, and ensure measurable production outcomes, as in what results are we getting. So this is what we will be implementing. So now we are going to get started with a case study, and I have two options as of now. So one would be a data set which we would be implementing across Hitachi, and one we will be taking a standard data set in order to see how these things works. Now, so I'm taking you to a business problem, and let's say the first problem which we are starting here is, let's say there is a problem of predictive maintenance optimization. Okay. And as an AI manager at Hitachi Digital, I have to ensure this predictive maintenance optimization needs to be implemented. So what is the task which an AI manager has to deal with? This is what we are going to discuss with this use case. Now the use case is anomaly detection in industrial IoT data, and we have to implement predictive maintenance optimization. So the objective is, let's say there is a problem. First, let us discuss the problem, and then we'll see what would be the solution. So basically, the task involves, let's say there needs to there is a need of a machine learning model which will detect anomalies in real-time sensor data from industrial equipment to prevent unexpected downtimes. This is what is required. So let's say as an objective, an AI model, an ML model needs to be built, and this model should detect anomalies in real-time sensor data which is coming from industrial equipments, and we have to ensure that there should be minimal downtime for these industrial equipments. Now, coming to Hitachi Digital. So Hitachi Digital, we all know, is a leader in providing innovative solutions for industrial operations, focusing on enhancing efficiency and reducing operational risks. So their primary customers are manufacturing and energy sectors, and these customers face significant challenges in maintaining equipment uptime and operational efficiency. So this is a problem which Hitachi Digital solves, let's say, for their economic customers, which are manufacturing units and energy sectors. So by leveraging advanced AI-driven solutions, Hitachi aims to create a cohesive vision that enables them to offer their products valued at $8 to $10 billion. So the vision is centered around predictive maintenance, where there is a critical need for their respective customers, where Hitachi needs to reduce downtime and operational costs for their economic customers. These could be manufacturing companies or energy companies. So now here comes the role of an AI manager, and we are going to get started with problem solving because in the document I have already discussed initially, let's say we're going to start from this project wise skill set, and the first is business problem discovery. So within this business problem discovery, we have to deal with problem solving, decision making ability, stakeholder and executive communication. And the objective of an AI manager here is to clarify the business problem, identify the users, what are the operational constraints, what is the expected value, and what is the impact of failure. So in this session, we will be focused on this part. Our objective is how an AI manager is going to clarify the business problem, identify the economic users or the users, those who are going to use the solution, what would be the operational constraints, what would be the expected value, and what would be the failure impact. Okay. And the use case is predictive maintenance optimization for Hitachi. Now, so we have to solve this problem. Now, what the problem statement is, industrial operations face significant risk due to unexpected equipment failures. This leads to costly downtimes and safety hazards. So this project aims to reduce the uncertainty of equipment failures by implementing real-time anomaly detection in sensor data. This is what needs to be implemented. And the economic customer. So the economic customer is a manufacturing plant manager who currently struggles with unexpected equipment failures, leading to production delays and increased maintenance costs. By completing this task, the plant manager will gain a reliable system for early detection of equipment anomalies, allowing for timely maintenance and reduced downtime. So this is what needs to be solved. Okay. So consider this is the problem statement, and this is the typical use case which we are solving in this particular case. Now, in order to have a data set, so there is one research-based data set which we took, and there is one synthetic data set which is available in order to solve this problem. Okay, so both of these data sets we can take up and we can parallelly use and solve. So apart from Hitachi, this is one standard data set. This is a Metro's data set. So the dataset says from a metro train in an operational context, readings from pressure, temperature, motor current, and air intake valves were collected from a compressor's air production unit. Okay. So this dataset reveals real predictive maintenance challenges encountered in the industry. It can be used for failure predictions, anomaly explanations, and other tasks. So here is one dataset which we can typically use in order to implement all the skill sets which are required for this use case. Okay. Apart from that, so there is this option. One, we can use this Metro Air Compressor dataset. So this dataset is a large dataset which has around 1.5 million rows, and this is also this we can use in order to quickly get started. Apart from this, there is one more option. I have a data set here, which will be our Hitachi's synthetic data set, which I'll just open and show. Okay, Hitachi. Yeah, I'll just take the data set from here. So I have a local copy available. I'll just upload it on Drive so that we can use the data set properly. Okay, so for this demonstration, we will get started with this MetroPT-3 data set. And the objective is to build an AI model in order to detect air leakages. So that would be our first, priority. And identification of air leakages in a real-time metro trains air production unit is one objective, and this we will relate with our, Hitachi's project. So one we will get started with this MetroPT-3 project, and we will do a cross implementation across our Hitachi dataset also. Okay, I believe this would be easy for you to understand and relate. So the problem statement is this, that there are certain production equipments which are running. There are certain industrial operations happening due to certain issues, due to some anomalies. Uh, there's a downtime of that equipment or the manufacturing plant. Okay. So for that, we will be using these two data sets. One is a standard MetroPT-3 dataset, and second one is the dataset which I created. This is a synthetic one for Hitachi synthetic data. Depending on my parameters which I have discussed with you. So I will eventually show you the parameters which I have taken into consideration in order to build this data set. So the overall objective of this system is to have the data set with this collection frequency where the temperature changes every 10 to 60 seconds, as in the frequency of this temperature collection is every 10 to 60 seconds. The pressure is every 1 second. Current voltage is every 1 second. Vibration is as per, hundreds of thousands of readings per second. Similarly, production load is every 30 seconds, and maintenance status is depending on a trigger event. So that is how the sensor is, that is how a standard sensor is generating record, and we are collecting on that, on that basis. And similarly, so all of these we will be taking into consideration. This is a time series data, and so we will be testing on these two. Now, in order to quickly get started, so what I have here is I have uploaded this data set on Google BigQuery. Okay. So now this data set is available to us on Google BigQuery. And here is the data set. I'm going to show you. This is currently, this is displayed from docs.google.com. But since the data set is large, I have connected this to Google BigQuery here to a project. So if you can observe here, so this is my cloud project, and this is my data set, MetroPT-3 Air Compressor, and this is the table which is on Google BigQuery. Okay. So I already have authenticated my account, and with that account, we are going to process it. Eventually, on your machine, we will see how we can get it done for your machine. Either you can, use the same repo, or we can have a copy on a local machine, and you can test it on Anaconda Navigator or a Jupyter Notebook locally available. So we will discuss and we will talk on it, how we are going to process it. So this is the data set which we are taking into consideration. Okay. Now, so the first objective is to understand what business problem, users, operational constraints, expected value, and failure impact we have to deal with. Okay. So for this, I have one document which we will quickly start. I think. Allow me a minute. So I have this document for end-to-end AI manager lifecycle, which we have to implement across MetroPT-3 project first. Okay. So we will be implementing all of these skill sets across discovery, governance, design, delivery, operations, and scale. Okay. So this is the end-to-end AI manager lifecycle which we will be implementing, and we will take care about business problem, the AI opportunity, uh, prioritization, backlog prioritization, how we are going to do that, and how we are going to take care of all of these. So if we quickly get started with the first skill which an AI manager must have is business problem discovery. This is one is the most important. This is one is the important one in order to get started. So if you can see here, uh, unexpected compressor degradations can delay trains. This is one issue. This increases emergency repair cost and it reduces asset reliability. So this is one problem which happens and which we will be dealing with this MetroPT-3 dataset. Okay. So what do we want to decide is, so we do need to take this decision, or there is a business decision or an analytical question which needs to be solved. So this is the analytical question. Should maintenance inspect the air production unit before a visible operational failure occurs? Okay. So this is the decision which needs to be taken care of. Now, what an AI manager has to do here, so the AI manager has to define warning lead time, false alert budget, escalation rules before selecting which model is going to whatever we are going to use depending on the data set analysis. Now here what we have is there are on the basis of this business problem discovery, there would be certain impact across these areas where safety, operations, finance, asset, and customer. These are the people, those who might get impacted. So as an AI manager, while we will be deciding while we will be strategizing, we have to take care across all of these impact factors, that how our decisions are going to impact these categories. So with respect to this problem, safety is one of the most prior one, then operations, finance, asset, and customer. So similarly, these are some operational consequences which will happen due to any of these delays happening in the system. So one is unstable pneumatic pressure risk, which may cause safety issues. Train removed from services, so there will be delay in metro operations. There could be emergency repair and downtime cost in case if it is not diagnosed at the right time. Eventually, emergency repair and downtime would definitely cost comparatively higher. And if that is happening across multiple, vehicles, again, it is going to be a bigger issue. Similarly, for an asset, we should have an accelerated compressor wear. That is an important part. Similarly, delay and reliability impact will cost on the customer's experience. So this is also very, very important for us as an AI manager to focus on. So initially, whenever we are going to get started with a problem, the overall objective is just not to write the AI model and get things done. We have to think with the perspectives of all different departments which would get impacted depending on the decision which we have to take. I believe this is clear, sir, so far.